If f is a PDF or the standard normal distribution, we can use numerical methods to find the values of the CDF. And because f is symmetric about z equals 0, we only need to compute values for z greater than 0. We can put these values into a table as CDF values for the normal distribution. To save space, the table is set up as a two-way contingency table. Typically, the row labels give the whole number and tenths, and the column labels give the hundreds. For example, we might use a table to find the value that the probability of a standard normal variable is less than or equal to 1.37. So the value 1.37 will be in the 1.3 row, 0.07 column. And we find since the table only gives us the CDF for non-negative values of our variable, we do need to use everything that we used before, so let's find the probability that x is greater than or equal to negative 0.38. So remember, the probability is the area. Let's graph the region. So this will be the area to the right of z equal negative 0.38. By symmetry, this is equal to the area to the left of z equals 0.38, which will be our CDF at 0.38. And we'll find this value in our table in the 0.3 row, 0.08 column. And we find or we might want to find the probability a random variable falls between two values. So remember, the probability is the area. Let's graph the region. This probability will be the area to the left of 1.43, from which we'll remove the area to the left of 0.21. So the probability will be the difference between our table values at 1.43 and 0.21. So referring to our table, f of 1.43 will be in the 1.4 row, 0.03 column, and we find f of 0.21 will be in the 0.2 row, 0.01 column, and we find so the only thing we've really added that's new is consulting the table. So this probability will correspond to the area to the left of 1.25, from which we subtract the area to the left of negative 1.53. We find the area to the left of 1.25 will be to find the area to the left of negative 1.53, we note that this is the same as the area to the right of 1.53. Which will be complementary to the area to the left, which is, and so the area to the left of negative 1.53 will be, and so we find